Hey guys, welcome back to my channel. So today I've created this practice paper for the GCSE edexcel Maths paper 3 that's going to happen on 11th June. So I have compiled different questions starting from 2018 to 2024. These questions are based on the topics that did not come in paper 1 and paper 2. So it makes it easier for you to revise everything through one document and, understand what you're supposed to do if any of those topics come. And I've attached the QR codes for my Instagram, TikTok, and YouTube account as well, where you can find plenty of resources for GCSE Maths for foundation and higher. Without further delay, let's start with the questions. So in the first question, we have a table which shows the class intervals for speed and the corresponding frequencies. They want us to find the model class. Model class is basically your highest frequency. So if you look at your table, we can see that the highest frequency is for the interval 20 to 30. That is your model class. Then find the class interval that contains the median. So for the median value, what we do is we divide the total frequency by 2. So 70 divided by 2 is 35. Now we see which class interval gives us the 35th value. So if you add 14 and 18, that gives you 32, which means the 35th value is going to come in this interval. So our model class is the same as the median, which is S is between 20 and 30. Apart from this, they can also ask you to find the estimated mean value for this data set. So for that, what you would do is you would find the midpoints of the class interval, multiply those with the frequency values, then add those products up and divide it by the total frequency, which is 70. That would give you the estimated mean. Then it says, draw a frequency polygon for this information. So to draw a frequency polygon, what we need is the midpoint of the class intervals and the frequency value. So let's first find the midpoint. So for 0 to 10, it's 5. For 10 to 20, it's 15. 20 to 30 is 25. And 30 to 40 is 35. These are your midpoint values. So now the x coordinate is going to be 5, 15, 25, 35. And y is going to be 14, 18, 26, and 12. So 5 and 14, let's plot that first. That's over here. Then for 15, we have 18. And for 25, it's 26. And for 35, it's 12. So once you've plotted your points, what we do next is we connect them with straight lines. So as you can see, for a frequency polygon, we only use straight lines to connect the points. We don't use curved lines. We don't use bars, just straight lines, where the x value is the midpoint and the y value is the frequency for the corresponding interval. Then it says Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the value of Jean's investment is £12,336. In the second year, the rate of interest is X over 2%. What is the value of Jean's investment at the end of 2 years? So if she's investing 12,000 for the first year, 12,000 times 1 plus X over 100 whole power 1. This gives us an investment of 12,336. So we can use this equation to find the value of x. First, we divide 12,336 by 12,000. That's going to be 1.028. Subtract 1. It's going to be 0.028. Then we times that by 100 to find the value of x. So 0.028 times 100. That's going to be 2.8%. Now they want us to find the value for investment at the end of 2 years. So at the end of 2 years is going to be 12,336 times 1 plus 2.8 over 200 whole power 1. That's going to be 12,336 times 2.8 divided by 200 plus 1, 1.014. And that gives us 12,508.7 pounds. So to recap, she's investing 12,000 and the rate of interest for the first year is X%. So when we invest that 12,000 after the first year, what we're getting is 12,336. So we use that equation to figure out the value of X. Then they said for the second year, the rate of interest is X over 2%. So X is 2.8. So 2.8 divided by 2 divided by 100 is 2.8 divided by 200, which is giving us a value of 1.014 when we add 1 to it. And then again times it by the value that we have after the first year, because it's that value that's been invested in the second year. So we use this for the second year, and then we find the investment value at the end of 2 years, which is 12,508.7 pounds. So Nimir was driving to a hotel, so he starts the journey at 13:30 and the destination distance is 65 miles. He arrives at the hotel at 14:48. We have to work out the average speed of the car from 13:30 to 14:48. So let's first find the time that is from 13:30 to 14:48. So in this question, Nimir is driving to a hotel. He starts the time at 13:30 and ends the journey at 14:48. The distance towards his destination is 65 miles. So to find the average speed, what we do is we divide your distance by time. So over here, we have the distance value, but we have to find the time value. That is between 13:30 to 14:48. So that's basically 1 hour and 18 minutes. If you convert that into hours, because they want it in miles per hour, 18 divided by 60 is 0.3 hours. So time is 1.3 hours, because 1 plus 0.3 is 1.3. So 65 divided by 1.3, and that gives us 50 miles per hour. That is your average speed. Next, we have a Venn diagram where the universal set has the elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A has the elements 1, 5, 6, 8, 9, and set B has the elements 2, 6, 9. We have to complete the Venn diagram to represent this information. So first we need to see what is common between A and B. We can see that they both have a 9 and they both have a 6. So the common elements will come in the middle, in the overlapping region, and the remaining elements go in their separate areas. So for A, we have 1, 5, and 8 over here. For B, we have 2 over here. Now, whatever is left behind in the universal set, that comes outside the circles. So we have 3, 4, 7, and that is it, because 1, 2, 5, 6, 8, 9 are inside. Yeah. So this is your complete Venn diagram. Then says a number is chosen at random from the universal set. Find the probability that this number is in the set A intersection B. Upside down U means intersection. So intersection is the common region. So we have 2 elements over here. So that's 2 over 9 elements in total, 2 over 9. Then it says find the probability that the number is in the set A complement. So A complement means the elements that are not in A. So for this, you just look at your Venn diagram and see which elements are not in A. So for not in A, we have 2, 4, 7, and 3. These elements are not in A. 4 out of 9. Then it says find the probability that the number is in the set A complement union B. So A complement union B would include 6, 9, 2, 3, 4, and 7. Everything that's outside of A. But 6 and 9 are also part of B, so they are included in our elements. So it's going to be 1, 2, 3, 4, 5, 6. 6 out of 9 is the probability of the number being in set A complement union B. Once again, in union, we include the elements that are also part of the other set, which are common between A and B. But if it was intersection, then you would not include 6 and 9, and you would also not include 3, 4, and 7. If it was A complement intersection B, then that would include just 2. So probability would be 1 over 9. But since it's A complement union B, that includes 2, 6, 9, 3, 4, and 7. Then it says ABC is a right angle triangle. AC is 14 centimeters. Angle C is 90 degrees. Size of angle B is to size of angle A is 3:2. Work out the length of AB. Give your answer correct to 3 significant figures. So it says the size of angle B is to size of angle A is 3:2. So if we say that this is 3x, this can be 2x. Okay, so if this is 90, we can find x by doing 90 plus 3x plus 2x equals to 180. 5x equals to 90, and x equals to 90 divided by 5, which equals 18 degrees. So we have to find the length of AB, which is your hypotenuse. So we can use either of these angles. If we use angle B would be 3 times 18, which is 54. And angle A would be 2 times 18, which is 36. So if we pick angle B to find the length of AB, then this becomes your adjacent, which is the length on which the angle lies. And the other length, which is opposite to the angle, becomes your opposite. So we need to find hypotenuse. We don't have the adjacent, but we do have the opposite. So which means we can use sine of angle B equals to opposite, which is 14 divided by AB, which is the hypotenuse. Remember your SOHCAHTOA. Sine is opposite of a hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So AB is going to be 14 divided by sine of 54, which gives us 17.3 centimeters, correct to 3 significant figures. That is your length of AB. Then it says in Spain, Sam pays 27 euros for 18 liters of petrol. In Wales, Leo pays 40.80 pounds for 8 gallons of the same type of petrol. 1 euro is equal to 0.85 pounds and 4.5 liters equal to 1 gallon. Sam thinks that petrol is cheaper in Spain than in Wales. Is Sam correct? You must show how you get your answer. So let's first find how much 1 liter costs in both Spain and Wales, and then we can compare it. So we have 27 euros for 18 liters. So let's convert them into pounds first. So if 1 euro is 0.85 pounds, then for 27 euros, we do 27 times 0.85, which gives us 22.95 pounds. Now 18 liters are for 22.95 pounds. So 18 is for 22.95 pounds. So 1 liter would be 22.95 divided by 18, which gives us 1.275 pounds. And then 1 gallon is 4.5 liters. So we can convert the gallons into liters. So for 8 gallons, we do 4.5 times 8, which is equal to 36 liters. So for Leo, he's paying 40.80 pounds. For 8 gallons. So we already converted the gallons to liters. So if 36 liters are for 40.80, then 1 liter is going to be 40.80 divided by 36, which gives us 1.13 recurring pounds. So the question was saying, is Sam correct? Because Sam thinks that petrol is cheaper in Spain than in Wales. No, Sam is wrong. And we can already prove that from the 1 liter cost. This is in Spain and this is in Wales. It's cheaper in Wales. That's why Sam is wrong. Since a number d is rounded to 1 decimal place, the result is 12.7. Complete the error interval for d. So if it's rounded to 1 decimal place, that means before it's going to be 12.65 and after it's going to be 12.75. Then the scatter diagram shows information about 10 students. For each student, it shows the number of hours spent revising and the mark the student achieved in the Spanish test. One of the points is an outlier, right in the coordinates of the outlier. So we can clearly see that this is our outlier because it's out of sync from the other points. So the coordinates are 4 and 10. Then it says for all the other points, draw the line of best fit and then describe the correlation. The line of best fit, we can pick these points because if we pick these points, we have 2 points above the line and 2 points below the line, which are not on the line. So this line is right in the middle of the given points. For the correlation, we can see that as the number of hours spent revising are increasing, so is the mark scored. So it's positive correlation. Then a different student studies for 9 hours. Estimate the mark gained by the student. So if you're studying for 9 hours, you draw a line between 8 and 10, and what I'm getting is 64. So the estimate mark is 64 for me. Then the Spanish test was marked out of 100. Lucia says, I can see from the graph that I revised for 18 hours. I would have gotten full marks. Comment on what Lucia says. So going back to the scatter diagram, we draw a line from 18 that's not even coming on the graph. As you can see, this is 18. So that's not coming on the line based on the given grade. So Lucia is wrong because it's outside the given range. Because her value is outside the given range. Then it says the group frequency table gives information about the times and minutes that 80 office workers take to get to work. So again, we have a table which shows the class items and the frequency values. We have to complete the cumulative frequency table. So when you're trying to find the cumulative frequency, what we do is we add up the consecutive frequency values. So for example, you start with the first frequency, which is 5, and then we do 30 plus 5, which is 35. Then we do 35 plus 20, which is 55. Then we do 55 plus 15, that's going to be 70. Then 70 plus 8, 78, and then 78 plus 2, which is 80. To make sure that the cumulative frequency values are correct, you need to cross-check your last value with the total frequency value given the question. If it's the same, that means your frequency values were correct. So this is how you check whether your cumulative frequency table is correct or incorrect. Then they're asking us to plot those values on the graph. So let's write on the values first. We have 5, 35, 55, 5, 35, 55, 70, 78, and 80, if I'm not wrong. Yeah. Okay, now for the intervals, when you're trying to plot the cumulative frequency graph, we always pick the maximum values. We don't pick the midpoint, we don't pick the middle value, we pick the maximum values. So for the maximum values for each interval, we have 20, 40, 60, 80, 100, and 120. So 20, 40, 60, 80, 100, and 120. So these are your coordinates. If you remember, for the frequency polygon, we chose the midpoint. For your over here, for the cumulative frequency, we pick the maximum value. So 20 and 5, that's going to come here. For 40, it's 35, so that's over here. 60, it's 55, that's over here. 80 is 70. 100 is 78. And 120 is 80. So we connect these. And this is a cumulative frequency graph. Use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. So for more than 90 minutes, you draw a line at 90 towards the graph. So we're getting 74 over here. So between 80 to 74, how many workers that take more than 90 minutes? That's 6. So 6 workers over here. We have to find an estimate for the percentage of these workers. So for the percentage, we will do 6 over 80 times 100, which equals 7.5. So 7.5% of the office workers take more than 90 minutes to get to work. In the cumulative frequency graph, they can also ask you to find the interquartile range, for which you need the upper quartile and the lower quartile. They can ask you to find the median value. So you need to be familiar with these things. For the upper quartile, we multiply 304 with the total frequency, which is going to be 80 in this case. And for the lower quartile, we find 1/4 of 80. And whatever value we get over here, then we plot that on the cumulative frequency chart and find the corresponding time value for that. And once we have those, we subtract them to find the interquartile range. So for example, if I find the one for this is going to be the 60th value over here and the 20th value over here. So if we go to the graph, for the 60th value, which is this, we're getting 55. And for the 20th value, this is the 20th, this is the 60th. So we're getting 55. So interquartile range would be 55 minus 5, and that's 50. That would be your interquartile range. 7.5%. Then Mario wants to find an estimate for the number of frogs in a lake. On Saturday, she catches 40 of the frogs. She puts a tag on each frog and releases them. On Monday, she catches 55 of the frogs. 7 of the frogs have tags. Work out an estimate for the total number of frogs in the lake. You must show all your working. So this question came in the 2024 paper, the October-November one, and this was different from what we've seen in the past. I think only one question I've seen that is similar to this one. So let's see if something similar to this would appear in this paper 3 or not. So we need to find the number of frogs in the lake. On Saturday, she catches 40 of the total frogs. So if we assume that total frogs are n, she is catching 40. She puts a tag on each frog and releases them. So all these have a tag attached to them. On Monday, she catches 55 of the frogs. So out of this n, she's caught 55 frogs. And 11 of the frogs have tags. So from these 55, 11 have a tag. So 11 out of 55 should be the same as 40 out of n. Because on Saturday, she caught 40 frogs and she put a tag on all of them. Then on Monday, she got 55 frogs and then she noticed that 11 of them had a tag on them. So this is your fraction for frogs that have a tag, basically. Because 40 out of n have a tag and 11 out of 55 have a tag. So to work out an estimate for the total number of frogs in the lake, we will do n equals to 40 times 55 over 11, which is 40 times 5, and that's 200. So 200 frogs approximately were in the lake. Then a box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per meter square on the floor. The face in contact with the floor is a rectangle of length 1.2 meters and width x meters. We have to find the value of x. So as you can see, pressure equals to force over area. We have the force, we have the pressure, we don't have the area, but what we do have is we have one of the lengths. So if we create the equation, it's 187.5 equals to 180 divided by 1.2 times x. So 187.5 times 1.2 times x equals to 180. Just cross multiply. So 187.5 times 1.2 is 225. So now for x, what we do is we divide 180 by 225, which gives us 0.8 meters. So that is your value of x. So the next question, it says that show that 3x over x plus 2 minus 2x plus 1 over x minus 2 minus 1 can be written in the form of ax plus b over x squared minus 4, where a and b are integers. So for algebraic fractions question, you can get something like this, or you can get a question where two fractions are being divided or multiplied. Can be anything out of these. So you need to know that when you have two fractions with unlike denominators being added or subtracted, our first step is to make the denominators equal. And that can only be done if we, in this case, multiply the first fraction by x minus 2, the second fraction by x plus 2, and the third fraction, or the whole number in this case, which is 1, by x plus 2 and x minus 2. So that's going to look like 3x times x minus 2 over x plus 2 times x minus 2 minus 2x plus 1 times x plus 2 over x minus 2 times x plus 2, then minus 1 times x plus 2 times x minus 2 over x plus 2 times x minus 2, like this. So now we can expand the bracket in the numerators. 3x squared minus 6 minus 2x squared plus 4x plus x plus 2 minus 1 bracket x squared minus 2x plus 2x minus 2. And this can be rewritten as a single fraction with the denominator is x plus 2 times x minus 2. So 3x squared minus 6 minus 2x squared minus 5x, because 4x plus x is 5x, and it becomes minus 2 minus x squared, and it's going to be plus 2. For the denominator, if we notice, it's x plus 2 times x minus 2, which is similar to difference of perfect squares, where a square minus b square is equal to a plus b times a minus b. So if you know difference of perfect squares, you can directly use that to rewrite this as x squared minus 4. Or if you don't know it, you can just expand the bracket like we did over here. And that would also give us, wait, this is 4. That would also give us x squared minus 4. So now combine the like terms. 3x squared minus 2x squared is x squared minus x squared. So the x squared goes away. Then we have there's an x over here. Sorry, I missed that. Negative 5x, negative 6x, that's negative 11x. And negative 2 plus 4 is plus 2 over x squared minus 4. So if we compare this with the fraction given in the question, ax plus b in the numerator, we do have that a is negative 11 and b is 2. Denominator is exactly the same. So this is how you would solve this question. Then it says make p the subject of the formula where t is equal to 2 times 2p minus 3 over 5 minus 2. So in this case, first let's expand the bracket. So that's 4p minus 6 over 5 minus 2p. Then we cross multiply to get rid of the fraction. So t times 5 minus 2p equals to 4p minus 6. Expanded. 5t minus 2pt equals to 4p minus 6. Remember, when you're rearranging a formula and changing the subject of the equation, you have to make sure that the variable that they want us to make the subject, all of the terms with that variable should be collected on one side. Since we have to make p the subject, so let's collect the terms with p on one side. So 5t plus 6 over here and 4p plus 2pt over here. Now, take p common. It's going to be p bracket 4 plus 2t. And then 5t plus 6 over 4 plus 2t equals to p. if you compare this with the original equation, we had two p's over there, one in the numerator, one in the denominator. But once we collected the terms with p on one side and took the p common, now we only have one p. So p equals to 5t plus 6 over 4 plus 2t, which is your final answer. Then it says factorize fully 15x cubed plus 3x squared y. So in these cases, what we do is we see what is the highest common factor. Highest common factor over here is 3 and x squared. So we take 3x squared common and we're left with 5x plus y in the bracket. So that's your fully factorized answer. We cannot further break this down. We cannot apply difference of perfect squares or anything. So this is it. Then simplify fully 3x to the power of 5, y to the power of 6 whole power 4. So whenever we have a power outside the bracket and inside the bracket, we multiply the powers. And the power gets distributed on the coefficient as well. So it becomes 3 to the power of 4 times x to the power of 5 times 4. And then y to the power of 6 times 4 as well. So 3 to the power of 4 is going to be 81. So remember, when there's a power outside the bracket and inside the bracket, the power gets multiplied. If we have similar bases being multiplied, you add the powers. If similar bases are being divided, you subtract the powers. Then expand and simplify. So we can expand this double bracket. It's going to be 4x times 4 minus 2x plus 3 times 4 minus 2x. So that's 16x minus 8x squared plus 12 minus 6x, negative 8x squared plus 10x plus 12. This is our expansion. You collect the like terms, and if it cannot be further simplified, you just leave it as it is. So negative 8x squared plus 10x plus 12. Then it says OAB is a triangle, OBC is a sector of a circle with center O. Calculate the area of OBC, giving answer correct to three significant figures. So to calculate the area of OBC, we obviously need the radius. And now if you notice, we have two lengths over here and the angle between it. We need to find the third length. So to find the third length, when you have two lengths and the angle between them, what we do is we use the cosine rule. So for the cosine rule, OB squared is going to equal to AB squared plus OA squared minus twice of AB times OA times cos of angle A. So that's going to be 9 squared plus 6 squared minus 2 times 9 times 6 cos of 35. 81 plus 36 minus 88.46. We multiply all of these together in one go. So that's going to give us, that's going to be 28.54. And then we square root both sides to find OB, which gives us 5.34 centimeters. And for the area of sector, our angle is 80. So 80 over 360 times pi r square. R is 5.34. And that is going to give us a value of 19.9 centimeters square. That is your answer. Before we move on to the next question, I have a small request from you guys. So I've checked out my channel analytics and I've noticed that almost 95% of my viewers have not subscribed to the channel. So I would really appreciate if you could help me out and subscribe to the channel. If you're someone who is liking my videos, who is understanding these questions better, please hit the subscribe button and make sure that that percentage for the viewers that are not subscribed, that changes and there are more subscribers. I would really appreciate that. Thank you. So now let's go back to the questions. The next question says that Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% each year for the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Jane bought it 3 years ago. So let's say the initial value is X. So at the end of the first year, the value decreased by 12.5%. So first year, if it's decreased by 12.5%, let's call this actually 100x. Yeah. Initial, the value is 100x. So if it's decreased by 12.5%, that means it's going to be 87.5x at the end of the first year. Then second year, it's decreasing by 10%. Now it's 78.75. And then again, it's decreasing by 10%. Now it's 70.875x. So you found 10% of 87.5, that gave us 78.75. Then again, 10% of 78.75, which gives us 70.875. This is what the value of the car is at the end of the third year. So if we put this equal to 17,010, that should give us the initial value of the car, which turns out to be 240 pounds. But that's X. So the initial complete value would be 240 times 100. 100 times X was the initial value, not X. So we times X by 100 to get the initial value, which is 24,000 pounds. Remember that when you're trying to calculate the percentages, you find 10% of 87.5 and then 10% of 78.75. You don't just subtract 10% of X from 87.5. That's going to be incorrect. You have to subtract 10% of 87.5, 10% of 78.75. So you have to be very careful about this. Then solve 6x squared plus 5x plus 6 equals to 0. So you have to factorize this quadratic equation. You can use the quadratic formula, splitting the middle term, whichever works for you. If we use the quadratic formula is x equals to negative b plus minus root of b squared minus 4ac over 2a. To figure out what the values of a, b, and c are, the quadratic equation comes in the format of ax squared plus bx plus c equals to 0, where a is the quotient of x squared, which is 6 for us, b is the quotient of x, which is 5, and c is the constant, which is negative 6. Remember to include the sign with the number. Do not write the number without its sign. If it's negative, you write the negative there. So x equals to minus 5 plus minus root of 5 squared minus 4 times 6 times negative 6 divided by 2 times 6. That's going to give us, let's solve the root first. So that's going to be 25 plus 4 times 36, which is 169. 169 is a square number because it's square of 13. So negative 5 plus minus 13 over 12. So one value of x is going to be negative 5 plus 13 over 12, which is going to be 8 over 12, which simplifies to 2 over 3. And for the other one is going to be negative 5 minus 13 over 12. That's negative 18 over 12, which simplifies to negative 3 over 2. So these are your values of x. X is negative 3 over 2 and 2 over 3. Then the nth term of a sequence is given by an squared plus bn, where a and b are integers. The second term of the sequence is negative 2 and the fourth term is 12. Find the sixth term. So Tn, which is the nth term, is an squared plus bn. We're saying the second term is negative 2. So T2 is going to be a times 2 squared plus b times 2, which is equal to negative 2. That's 4a plus 2b equals to negative 2. That's the first equation. Then the fourth term is a times 4 squared plus b times 4 equals to 12. That's 16a plus 4b equals to 12. That is your second equation. So you can solve these two simultaneously to find the sixth term. So to solve it simultaneously, I can multiply the first equation by 2. So that's going to be 8a plus 4b equals to negative 4. And we have 16a plus 4b equals to 12. Subtract the two equations because I'm trying to eliminate the variable b. To eliminate variable b, we need to make sure that the coefficients are same. We already did that. Then we need to check their signs. Both b's are positive, which means to get rid of it, we need to subtract the two equations. So 8a minus 16a is negative 8a. 4b minus 4b is 0. And negative 4 minus 12 is negative 16. Which means a is going to be negative 16 over negative 8, which is 2. And to find b, we can put it back into either equation 1 or 2. If I put it in equation 1, it's 4 times 2 plus 2b equals to negative 2. 2b equals to negative 2 minus 8. That's negative 10. And b is negative 5. So for the sixth term, that's going to be 2 times 6 squared minus 5 times 6. That equals to 2 times 36 is 72 minus 30. That's 42. So 42 is your sixth term for this sequence. Then it says here are the first 5 terms of a different quadratic sequence. Find an expression in terms of n for the nth term of the sequence. So let's first begin with find the common difference. So we have 0, 2, 6, 12, and 20. The difference between 0 and 2 is 2, between 6 and 2 is 4, between 12 and 6 is 6, and between 20 and 12 is 8. Then we again find the difference because the first difference is not common. So that's 2, 2, and 2. First difference, second difference. Remember that in a quadratic sequence, your second difference will always be common, not the first. So once you have found the second difference, what you do is you divide the second difference by 2. Second difference is 2 in this case, so 2 divided by 2 is 1. So this 1 becomes your coefficient of n squared. So we assume that Tn is n squared in this case because the coefficient of n squared is 1 based on this. So now what we do next is we create a table where we have the terms, so the original term, and then we have the n squared. We assume that this is the nth term, like I said before. So original term is 0, 2, 6, 12, and 20. If we use n squared as the nth term, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 square is 16, and 5 square is 25. These are the terms that we get for the nth term of n square. Once we found the terms using n squared, next what we do is we subtract the two. Subtract n square and the OT. So 1 minus 0 is 1, 4 minus 2 is 2, 9 minus 6 is 3, 16 minus 12 is 4, and 25 minus 20 is 5. So with these terms, we create another sequence. So if we create a sequence out of these terms, we can see that 1, 2, 3, 4, and 5 all have a common difference of 1. So based on the pattern of this sequence, we can say the nth term would be n. Because n equals to 1 is 1, n equals to 2 is 2, n equals to 3 is 3, and so on. Which means the nth term of the quadratic sequence would be n squared plus n. We add these two. This is the square component of the quadratic sequence. This is the linear component. So overall sequence is n squared plus n. So to summarize this, first you begin with finding the common difference. The first common difference is not common, so which means you find the second difference, and the second difference is common because it's a quadratic sequence. So whatever that value is of the second difference, you divide it by 2, and that becomes the coefficient of n squared. So in this case, it was 2, so 2 divided by 2 was 1. So coefficient of n squared was 1. So we had Tn equals to n squared as the potential nth term for the sequence. Then what we did was we created a table where one column was for values that we get from n squared, and the other column was for the original terms in the sequence. So for n squared, we can see that we got 1, 4, 9, 16, and 25, whereas the original terms were completely different. So what we did next was we subtracted the original term numbers from the n square numbers, and whatever values we got, we made another sequence out of that. And using that sequence, we tried to calculate the linear part of the quadratic sequence. And we can see that that sequence had an nth term of n, which means the overall sequence becomes n squared plus n, which is your answer. Then it says here's a prism ABCD SPQR, and the ABCD of the prism is a square of side 14 centimeters, which means this is also 14, this is also 14, and this is also 14. T is the point on BC such that BT is to TC is 4 is to 3, which means BT is going to be 4 over 7 times 14, and that's going to be 8 centimeters. And TC is going to be 14 minus 8, which is 6 centimeters. So we have that sorted. This is 8, this is 6. Then the cross section of the prism is in the shape of a trapezium. This is your cross section. And it has an area of 147 centimeters square. CR is given as 12. So that means QB would also be 12. Find the size of the angle between ST and the base ABCD. So basically, we have to find this angle. So to find this angle, we can clearly see that we need the length of DT. We need the length of SD or ST. Any one of these is needed to find the angle. So we can calculate the length of DT very easily because this is a right angle triangle. DCT. It's a right angle triangle. We have this length as 14, DC, and TC is 6. So we can easily find DT using Pythagoras. DT squared is going to be 14 squared plus 6 squared, which is 196 plus 386, which is 232. And then we take the square root on both sides. So dt equals 15.23 centimeters. Okay. Now, if we notice, they told us that the area of the cross section is 147. So for the area of the cross section, what we need is the height and two parallel sides. PA and DB are the parallel sides and the height is AB. So we have one length, we have the height, we need the parallel sides. So we can easily use the trapezium formula to find that length. So area of trapezium is 1 over 2 times height times sum of parallel sides. So A and B are the parallel sides. So that's 147 equals to 1 over 2 times 14, which is your height, and A plus 12. Because CR was 12, so that means QB would also be 12. So that's 147 divided by 7 minus 12 equals to A. 9 centimeters is A. So if this is 9, SD is also 9. So if you make a rough triangle over here, S, D, and D, this is 9. DT is 15.23. We need to find this angle. So we'll use tangent because opposite is 9 and adjacent is 15.23. So tan theta equals to 9 over 15.23. Tan inverse of 9 over 15.23. That gives us 30.6 degrees, correct one decimal place. This is the angle that the length ST makes with the base ABCD. So for this, 3D trigonometry questions, you need to remember SOHCAHTOA, you need to remember Pythagoras, you need to be able to recognize where a right angle triangle exists in the 3D shape and how you can use it to find the missing information. And you need to know the formulas for like trapezium or parallelogram, depending on what the cross section is of the shape. You need to remember your area of triangle formula. All of these formulas are very important for this. Then it says A, B, C, and D are 4 points in a circle. SBT is a tangent to the circle. Angle ABD is given as 20. The size of angle BAD is to the size of angle BCD is 3:1. Find the size of angle SBA. Give a reason for each stage of your working. SBA, we need to find this angle. Okay, this is your tangent. And what else do we know? The size of angle BAD, this angle, and BCD. So if this is X, this is 3X. 3:1. So if you notice, the quadrilateral ABCD, it's cyclic quadrilateral. In a cyclic quadrilateral, your opposite angles add up to 180, which means 3x plus x equals to 180. And the reason for this is cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. The cyclic quadrilateral, all of your vertices need to touch the circumference, which is exactly what's happening over here. So 4x equals to 180. X would be 180 divided by 4, and that is 45. Which means BCD is 45 and BAD would be 45 times 3, which is 135. So this is 135. This is 45. So now for SBA, we can find this angle because ADB is making a triangle. So sum of angles in a triangle is 180. So we already have two. You can find the third one. So BDA would be 180 minus 135 minus 20, which is going to give us 25. So sum of angles in a triangle equal to 180 degrees. That's the reason for this step. This one was given. Then, so that's 25. We can do is we can use the alternate segment theorem. Yeah. In alternate segment theorem, this angle is equal to this angle, and this angle is equal to this. So if this is 45, that means this is also 45. So SBA is basically 45 minus 20, which is 25 degrees. Why? Alternate segment here. That is the reason for this. So based on alternate segment theorem, this complete angle SBD is 45. So since SBD includes SBA and ABD, so when we subtract the two, we get SBA, which is 25. So that is your answer and reasons for each of the steps. Then says here is a frustum of a cone. The diagram shows that the frustum is made by removing a cone with height 3.2 centimeters from a solid cone with height 6.4 centimeters and base diameter 7.2 centimeters. The frustum is joined to a solid hemisphere of diameter 7.2 centimeters to form the solid S shown below. The density of the frustum is 2.4 grams per centimeter cube and the density of the hemisphere is 4.8 grams per centimeter cube. We have to calculate the average density of solid S. So to calculate the average density, we need the volume of solid S, and to find the volume of solid S, we need the volume of the hemisphere and the volume of the frustum. So for the volume of frustum, what we can do is, so if we look at the cone first, the entire cone, we can see that that has a height of 3.2 plus 3.2, which is 6.4. So this is 6.4. The cone that was removed that had a height of 3.2, that leaves us with 3.2 for the frustum. So the cone that's removed and the cone that was the entire whole cone, they're both similar cones. So this and this, they're similar. So we know that the height for this is 3.2 and for this is 6.4. So why don't we use that to figure out the scale factor? And then using that scale factor, we can figure out the diameter of the small cone. Because for the big cone, it's 7.2. But for the small cone, we don't know that. So for the scale factor, we know that 6.4 divided by 3.2 is equal to 2. Which means to find the diameter of the small cone, which is x would be 7.2 divided by 2, which is 3.6 centimeters. So radius of small cone would be 3.6 divided by 2, which is 1.8 centimeters. And radius of large cone would be 7.2 divided by 2, which is 3.6 centimeters. So once we have the radius covered, we can easily use that to find the volume of the frustum, because volume of the frustum is going to be volume of the big cone minus volume of the small cone. So volume of frustum That's going to be 1 over 3 pi r squared, which is 3.6 squared, times the height, which is 6.4, minus 1 over 3 pi times 1.8 squared times 3.2. Let's separate this. So that's going to be 1 over 3 pi. We can take that common over here and do 3.6 squared, 12.96 times 6.4. That's 82.944 minus 1.8 squared times 3.2. That's 10.368. So 82.944 minus 10.368 divided by 3 times pi, that's 76.00 centimeter cube. That is the volume of the frustum. Before we go to the density part, let's find the volume of the hemisphere as well, because we need that. Volume of hemisphere, that's going to be 2 over 3 pi. R is going to be that of the large cone, so that's 3.6. 2 over 3 pi r cube. So that gives us 3.6 cube times 2 times pi divided by 3. That's 97.72 centimeter cube. Okay, now that we have the volume of the frustum, volume of the hemisphere, next what we need is the mass. So for the mass, we'll use the density formula. Density equals to mass over volume. We need the separate mass of both the frustum and the hemisphere. So mass of frustum would be the density of frustum, which is given as 2.4 in the question. So 2.4 times the volume of the frustum, which is 76. That gives us 182.4 grams. Then mass of the hemisphere, that's going to be the density of the hemisphere, which is 4.8 times 97.72. That's going to be 469.056 grams. Now to find the average density, what we do is we find the sum of the mass and divide by the sum of the volume for both the frustum and the hemisphere. So basically what I mean is that which density is going to be total mass of solid S divided by total volume of solid S. So total mass is going to be 469.056 plus 182.4, and total volume is going to be 76 plus 97.72. 469.056 plus 182.4 divided by 76 plus 97.72. That's coming out to be 3.75 grams per centimeter cube. I think they wanted the answer in 3 significant figures. They haven't specified it, so you just give it as 3 significant figures. So this is your average density. Then it says the curve C has equation y equals to x squared plus 3x minus 3, where the line L has equation y minus 5x plus 4 equals to 0. We have to show algebraically that C and L have exactly one point in common. So, which means we're going to solve them simultaneously. But in this case, we're not going to use elimination method. We're going to use substitution method. Why? Because in a quadratic equation, trying to show the intersection between a quadratic curve and a linear equation, always go for substitution, because in elimination you cannot eliminate it, because it's an x square in one equation and the other only has the highest power of 1 for x. So eliminating it is going to be really time consuming and hard. So it's best to go with the easier option, which is substitution in this case. So what we do is we first make y the subject for the linear one. So that's 5x minus 4. Let's call this the third equation. This is the first, this is the second. We substitute 3 in 1. So that's going to be 5x minus 4 equal to x squared plus 3x minus 3. Collect all the terms on one side. So x squared plus 3x minus 5x minus 3 plus 4. That's going to be x squared minus 2x plus 1. Now we solve this quadratic equation. We use the quadratic formula. X equals to minus negative 2 plus minus root of negative 2 squared minus 4 times 1 over 2 times 1. That's 2 plus minus 4 minus 4 over 2. That's 0 over here. So 2 divided by 2. And that gives us exactly one value, which is x equals to 1. And to find the corresponding y value, you put x equals to 1 in your equation number 2. So that's y equals to 5x minus 3. Sorry, third equation. So y equals to 5x minus 4. So that's 5 times 1 minus 4, and that is 1. So your coordinates are 1, 1. And as you can see, there is no other point. So that clearly shows that it's only intersecting at one point, not two. Then it says, here's a sketch of the graph y equals to tan x. The graph of y equals to tan x is translated to give the graph of y equals to g of x. Following the translation, the point Q shown on the graph above moves to the point R. Point R has the coordinates 90 and negative 5. We have to find an expression for g of x in terms of x. So 90 and negative 5 is going to be somewhere over here. And 90 is this asymptote. For the tan graph, we have asymptotes after every 180 degrees. So we have an asymptote at 90 degrees. This is the line through which your graph cannot intersect. Then we have it at 270. And then we again have it over here. So it intersects the graph at basically 0, 180, and 360. That is the tan graph. So to understand how the translation has taken place, we can see that it went from, this is your point R. So it went in this direction. So from 360, it went to 90. So that means it went 270 degrees to the left-hand side. When it's going to 70 degrees to the left-hand side, that means we are adding 270 to x. If it was 270 degrees to the right-hand side, that means you were subtracting 270 from x. So x plus 270, and then it's at 0 over here. Now it's negative 5, which means it went down 5 units. So g of x is going to be tan of x plus 270 and then minus 5 outside the bracket. If you're someone who struggles with understanding the transformation of graphs, I can attach a link to my video on transformation of graphs, and you can go through that and develop better understanding about how to transform graphs, whether they're trigonometric or the quadratic, cubic, any one of the graphs. Then the equation of a curve is y equals to 4x squared minus 56x. The curve has one turning point. By completing the square, show that the coordinates of the turning point are 7 and negative 196. You must show all your working. So basically, in this case, they're asking us to use completing the square method to figure out what the turning point is going to be. So for completing the square method, what we can do is, first we begin with taking 4 common from the entire equation. Because the quotient of x squared has to be 1. It cannot be more than 1 or less than 1. So it's going to be 4 bracket x squared minus 14x. We only take 4 common, not x, just 4. Now we have to complete this square. So complete square basically looks like a minus b whole square or a plus b whole square depending on what the sign is over here. So since it's x squared minus 14x, that means we're looking at a minus b whole square. A minus b whole square expands to a square minus 2ab plus b square. Over here, if we compare our x squared minus 14x with this, we can see that we have our a value, which is x, but we don't know what b is. That's what we're trying to figure out to complete this square. So to figure the b value out, what we do is we put 14x equals to 2ab. A is x, so replace a with x, so it becomes 2xb. Now 14x divided by 2x is 7. So b is 7, which means to complete the square, we will add a 7 squared in the bracket, but we will subtract it as well. The reason why we're subtracting it as well is because there was no plus 7 squared in the equation. We just randomly added it. So to maintain a balance, we have to subtract it as well. So there's going to be a minus 7 square as well. So y equals to 4 times bracket x minus 7 whole square. This is now your complete square as this. If I highlight this is the same as this then. And now outside the bracket, we have this negative 49. So now when you multiply the 4 with the brackets, so x minus 7 whole square, and then 4 times 49, that's going to be 196. So this is your complete square form. And for the turning point, the number that's being added or subtracted to x, that's your x value of the turning point, and the number that's outside, that's your y value. So we can see that it's 7 and negative 196, as shown in the question. Then say CDEF is a quadrilateral. Vector CD is A, so this is A. DE vector is B. And FC vector is A minus B. Express FE in terms of A and or B. Give your answer in simplest form. So FE can be FC plus CD plus DE. FC plus CD plus DE. So FC is A minus B, plus CD is A, and D is B. So that's 2A. That's your vector FE. Then it says M is the midpoint of DE. So that means DM is going to be over 2 and ME is also going to be B over 2. X is the point on FM such that Fx is to XM is N is to 1. CXE is a straight line. We have to work out the value of N. So we can see that X is common on both the lines CXE and FXM. So what I would like to do is I would like to find two vectors for Fx. And I'll put them equal to each other to figure out what the value of N is going to be. So we know Fx lies on Fm. So we can say that one equation for Fx is going to be N over N plus 1 times Fm. So let's find Fm first. Fm is Fc plus Cd plus Dm. So that's A minus B plus A plus B over 2. So that's 2a minus 2b plus b over 2, which is 2a minus b over 2. So let's write this as 2a minus 0.5b. That's fm. So fx is n over n plus 1 times 2a minus 0.5b. That is one equation for fx. Now, another equation for fx is going to be fc plus cx or fe plus ex. But since we do have fc and both fe, we can use either of these. I'm going to choose fc plus cx. There's no compulsion for that. So another equation is fx is fc plus cx. Now we have fc, that's a minus b, but we don't have cx. However, we know cx lies on ce, and we can figure out the value of the vector ce by doing cd plus de. So ce is going to be cd plus de. So cd is a, and de is going to be b. So a plus b is ce. So cx is some scale factor times a plus b. That's cx. So fx is also a minus b plus k times a plus b. If we collect all of the vector a complex and b complex, so a is 1 plus k, and for b it's k minus 1. These are the coefficients of a and b. Now, since both vectors fx represent the same thing, we can put the equations equal to each other to figure out the value of n and k. So n over n plus 1 times 2a minus 0.5b equals to a times 1 plus k plus b times k minus 1. So if we expand the bracket, 2n over n plus 1 gets multiplied with a, and negative n over n plus 1, 0.5 n actually, gets multiplied with b. Okay. And that's a times 1 plus k over here, plus b times k minus 1. So we put the coefficients of a equal to each other and b equal to each other. So 2n over n plus 1 is equal to 1 plus k, and negative 0.5 n over n plus 1 is equal to k minus 1. Since we're trying to find the value of n, so let's make k the subject over here and replace the k in the other equation with this expression. So it's going to be 2n over n plus 1 equals to 1 plus negative 0.5 n over n plus 1 plus 1. So 2n over n plus 1 equals to 2 minus 0.5 n over n plus 1, because 1 plus 1 is 2. Make the denominator same over here, so that's n plus 1, and 2 times n plus 1 minus 0.5 n. So that's 2n over n plus 1 equals to 2n plus 2 minus 0.5 n over n plus 1. The n plus 1 get cancelled out, so we're left with 2n equals to 1.5 n plus 2. 2n minus 1.5 n equals to 2, which is 0.5 n. So n is going to be 2 divided by 0.5, which gives us the value of 4. So n equals to 4. So for vectors, remember that you have to just pick a vector, make two equations for it, put them equal to each other, then figure out the value of the unknown variables, which in this case was n and k. Since they wanted the value of n, so we directly, made an equation where there was only n. We replaced the k with n as well, and then solved that for n, instead of finding the value of k first and then finding n. Then since the straight line L has equation 3x plus 2y equals to 17, the point A has coordinates 0, 2, and the straight line M is perpendicular to L and passes through A. Line L crosses the y-axis at the point B. Lines L and M intersect at the point C. We have to work out the area of triangle ABC. You must show all your working. So if L and M are perpendicular, that means the gradient of L, let's call that M1, and gradient of M, which is M2, the product of both these gradients will always equal to -1 because they're perpendicular. So using this, we can figure out the gradient of the line M. First, let's take the equation for line L, convert this into slope-intercept form by making y the subject. This way, we can figure out what the M1 value is. So y equals to -3 over 2x plus 17 over 2. M1 is -3 over 2. Gradient is always the coefficient of x in slope-intercept form. Slope-intercept form is y equals to mx plus c, in case one of you doesn't know about that. So, which means M1 times M2 is -1. -3 over 2 times M2 is -1. So M2 would be 2 over 3. Now, the line M is passing through the point A, and point A has the coordinates of 0, 2. So we can use the point A and this gradient value to figure out the equation for line M. Y equals to mx plus c. Y is 2, M is 2 over 3, x is 0, and c is what we're trying to find. So that's 2 equals to c. So y equals to 2 over 3x plus 2 is your equation for line M. So since line M and line L are intersecting at the same point, which is point C, we can solve these two simultaneously or put them equal to each other to figure out the value of C. If I put them equal to each other, so -3 over 2x plus 17 over 2 equals to 2 over 3x plus 2. These are the two equations. So let me highlight this. This is line L. So multiply the entire equation by 6 to get the fraction. So times that by 6. So that's -9x plus 51 equals to 4x plus 12. Select the like terms on each side. So 51 minus 12 equals to 4x plus 9x. 51 minus 12 is 39. And 4x plus 9x is 13x. So 39 divided by 13, and that's x equals to 3. To find the y value for C, we can put x equals to 3 in either of the equations. If I choose line M, y would be 2 over 3 times 3 plus 2. That's 2 plus 2, and y equals to 4, which means C is going to be 3, 4. First, to figure out the area of triangle ABC with the coordinates of B as well. So if you look at the question said that the line L crosses the y-axis point B. So if we put x equals to 0 in line L, -3 over 2x plus 17 over 2, put x equals to 0. So that's y equals to -3 over 2 times 0 plus 17 over 2, where y equals to 8.5, which means b is 0 and 8.5. Now, if we roughly sketch it, a was 0, 2, b is 0, 8.5, and c is 3 and 4. Yeah. So 3 and 4. So this is where your right angle is over here. Because the lines L and M are intersecting over here. This is M and this is L. Now, if you look at this triangle, we can say that AB is the base and this is your height. So area would be 1 over 2, height is 3, and base is 8.5 minus 2. So that gives us 9.75 units square as the area of the triangle ABC. And that's your answer. Then the next question says that the time period t seconds of a simple pendulum of length L centimeters given by the formula t equals to 2 pi times L over G square root. Katie uses a simple pendulum in an experiment to find an estimate for the value of G. Here are her results. L is 52 centimeters correct to 3 significant figures, and time is 1.45 seconds correct to 3 significant figures. We have to work out the upper bound and the lower bound for the value of G, using pi as 3.142. You must show all your writing. So first, let's make G the subject of the formula. It's T equals to 2 pi root of L over G. So T divided by 2 pi first equals to root of L over G. Then we square both sides to get rid of the square root. So it's T squared over 4 pi square equals to L over G. And G would equal to 4 pi square times L over T square. That's G. Now, if we look at the value of L and T, L is 52 correct to 3 significant figures. So if it says 3 significant figures, what we do is we check what the third significant figure is. Third significant figure is 0 over here. So now we see what is the place value of that significant figure. So place value of 0 is 0.1. So for L, we divide the place value by 2. So 0.1 divided by 2 is 0.05, which means for upper bound, it's going to be 52 plus 0.05, which is 52.05 centimeters. And for the lower bound, we do 52 minus 0.05, which is going to be 51.95 centimeters. Similarly, for T, we look at what the third significant figure is. Third significant figure is 5. Now we see what is the place value of 5. Place value of 5 is 0.01. So what we do is we divide the place value by 2, which is going to be 0.005. Now, same thing for the upper bound. We do 1.45 plus 0.005, which is 1.455 seconds. And for the lower bound, we do 1.45 minus 0.005, which is going to be 1.445 seconds. The question was asking us to find the upper bound and the lower bound of G. So for the upper bound of G, our numerator will be upper bound and denominator will be lower bound. For the lower bound of G, numerator will be lower bound and denominator will be upper bound. G would be 4 times 3.142 squared times the upper bound of L is 52.05 divided by lower bound of t, 1.445 squared. That gives us 984.37. And then for the lower bound of g, g would be 4 times 3.142 squared times the lower bound of L now, which is 51.95, divided by the square of the upper bound of time, 1.455 squared. That equals 969.02. So upper bound is 984.37 and lower bound is 969.02. That's your answer. In case it was saying that it's correct to like some decimal places or like to the nearest meter. So if it was correct to two decimal places, let's say, so then you would do 0.01 divided by 2 and then add and subtract that value for the upper and lower bound. And for nearest meter, you would just divide 1 by 2. So 0.5 would be added and subtracted to the value given for the variable that we're finding the upper bound and lower bound for. It says ACF and ADG are straight lines, BCD and EFG are parallel lines. Show that the triangle ACD is isosceles. Give a reason for each stage of your working. So if BCD and EFG are parallel lines and ACF and ADG are straight lines. So firstly, alternate angles are equal in parallel lines. So if this is 125, this is also 125. So angle FCG equals to 125 because alternate angles are equal in parallel lines. We have to prove that ACD is isosceles. So if this is 125, this is going to be 55. Why? Because angles on a straight line add up to 180. So CFG equals to 55. Angles on a straight line add up to 180 degrees. Then after that, this angle would be 70. Why? Because co-interior angles add up to 180. So DGF equals to 70 degrees because co-interior angles add up to 180. Alternative method was that you would have subtracted 125, 55, and 110 from 360 because this makes a quadrilateral. And then that would have given us 70 as well. Now, after that, we need to find angle A because we have to prove that ACD is an isosceles. So for angle A, FAG would be 180 minus 70 minus 55. That gives us 55. So this is 55. And the reason being that sum of angles in a triangle equal to 180. Okay, now that we know that ACF and ADG are straight lines, so this would be 55 and this would be 70. So ACD equals to 55. Again, angles on a straight line add up to 180 and ADC is 70. Because again, angles on a straight line add up to 180. So as you can see, we have two equal angles over here, angle A and angle C. So that means these two lengths are also equal, which shows us that it's an isosceles triangle, because in an isosceles triangle, we have two equal lengths and two equal angles. Since angle ACD equals to angle CAD, which is 55, that shows that ACD is an isosceles triangle. That is how you prove your answer. Then it says, here's the graph of y equals to f of x. On the grid below, draw the graph of y equals to f of x minus 4. So if something is being subtracted directly from the function, that means you move that many units down. So this trapezium goes 4 units down. So 0 becomes -4. There's 0 over here goes down to this. 1 comes down to this and this. So this is your graph. We went 4 units down. So from 1, we came to -3. From 0, we came to -4. Then draw the graph of y equals to f of -x. So when your x value is negative, that means you're reflecting the graph in the y-axis. So when you're reflecting it in the y-axis, -3 becomes +3. So that's going to come over here. And the other one was -2, 1 becomes +2, 1, and -1, 1 becomes +1 and 1. So they're going to come over here. So now we connect the points, and that's our trapezium. Obviously, you'll draw these using the ruler with straight lines. So that would be your correct sketch of the graph. And with that, we're done with the questions. If you have any confusions about any of these, leave a comment below. I try to help you out. These were the topics that did not appear in paper 1 and paper 2, so they're most likely to appear in paper 3. Try to include as many topics as I could. If I've left something and you want me to do a separate video on that, please let me know in the comments below, and I'll try to make one for it for the exam.